2019. He was a past president of Asire Bangalore chapter. He is a member of Indian Green Building Council, Indo Air Quality Association, Association of Ammonia Refrigeration, Fire and Security Association of India. Thank you, sir.
Ravi sir.
Sir, yes, sir.
Proceed, sir.
ஸ்டார்ட் பண்ணிடலாமா? வேற ஏதாவது சொல்லுங்க.
டிஸ்க்ளைமர் இருக்கு சார்.
டிஸ்க்ளைமர் மட்டும் இது பண்ணிருங்க சார். டிஸ்க்ளைமர்.
Sir, please.
Yeah, I will read it, sir. Disclaimer. The information provided within this webinar is for general informational purposes only. While we try keep the information up to date and correct, there are no representations or warranties expressed or implied about the completeness, accuracy, reliability, sustainability, or availability with respect to the information, product, services, or related graphics contained in this webinar for any purpose. Any use of this information is at your own risk. We do not guarantee or declare that the information on the webinar is accurate and correct. We are not responsible, nor can they be held liable for any errors or hiatus in the content of the webinar. Speaker, the view expressed in presentation made at webinar or other webinars are those of the speaker and not necessarily of ISHRE. Presentations or the presence does not constitute an endorsement of the vendor of speaker's views, products, or services. Thank you. Sir, you can start, sir.
Okay, thank you. Good evening, all of you. இது இருக்கிறதுக்காக கொஞ்சம் ஸ்பீடு வீடியோ இது பண்ணிக்கிறேன் நான். குட் ஈவினிங் ஆல் ஆஃப் யூ. இட்ஸ் நம்ம மதுரை சாப்டருக்கு ப்ரெசென்ட் பண்ணுறதுல ரொம்ப மகிழ்ச்சியாக இருக்கு. It's very nice to be here part of the Madurai chapter. Screen தெரியுதா?
Visible sir.
Okay. இப்போ நம்ம இன்னைக்கு என்ன சப்ஜெக்ட்னா பில்டிங் மேனேஜ்மெண்ட் சிஸ்டம் டேட்டா அனலிட்டிக்ஸ். இது வந்து ரொம்ப this is an important field because it's growing field. This is growing along the various technologies whatever we are talking about. The IT field வந்து IT field when that is growing, this is also parallelly, we have to update. It automatically gets updated and it is also going to be one of the most important field actually. நம்மளே பார்த்தா கையில each one of us is having minimum or 3 to 4 devices இருக்கும். Mobile we have laptop, maybe we have tab or iPad, then கையில வந்து watch also we may some of us are having smart watch. அது மாதிரி பார்த்தா we going forward, what they are saying, every person may have minimum 5 to 6 intelligent smart devices along with them in every family. So that means all the information whatever we are talking about regarding whatever we do, either personal life or professional life, I think they are all driven by digital world now. They are going to rule. So why leave the most important aspect, which is the BMS and data, which is for our important thing, which is HVAC and MEP equipment, because that is the thing which is most important for every building actually. So now for today's presentation, I have broken it up into basics, a little bit of understanding of BMS so that it is catering to entire spectrum of people who are here. For some of you, it may be a little bit basic. Please pardon me if you will be already knowing about it, but I will try to share my experience. Then what does it do? BMS architecture, we will see functionality, MEP services integration. Then we will see what some point list of air handling units, chiller plant management. Then how data analytics, it's very important for building and summary. So if we go through the journey of smart buildings, what we have 1900s, we had only pneumatic controls. Like if you know, a long time before, when we want to control this VAV air handling unit, the speed of AHU, we used to have something called static pressure regulator. That is, I remember Honeywell, we used to install this Honeywell static pressure regulators, but it's very complicated kind of pneumatic system. Okay, but that was what is available in 1900. Now coming from there, 1970s, the supervisory system, energy management system started coming. Now 1980s, DDCs started coming, Modbus protocol, all that started coming. Then 1990s, that is 1995, the most important thing breakthrough was ASHRAE BACnet. ASHRAE BACnet standard, I remember 1987, the first committee was formed with all the manufacturers from all the various BMS companies and end user, that is owner from university and so many others. So they were all, they took almost 7 years to come up with that ASHRAE BACnet standard. In 1995, that BACnet standard came. Right. The need was because take any building or multiple buildings, for example, 2010, they might have gone for one brand, one supplier. 2012, they would have gone for another supplier for BMS or for chillers or for VAV box. 2015, for another building or expansion, they might have gone for another vendor, another BMS supplier. Now, if you want to connect it to one PC software and monitor everything, then you are likely to have problem because you have multiple vendors, multiple systems and all. So you cannot keep 10 computers, 10 software and things like that. So which means you have to have a platform where all the equipment from various manufacturer, various functionalities, they should be able to transfer data, exchange information for ease of operation purpose, my maintenance people and operations people. And that was the main reason why that ASHRAE BACnet standard came. And that was in 1995. Then 2000, we started having wireless, IP, because IT field, we have to remember that IT technology, IT space, lot of, revolution started happening during that period, right? So parallelly, this industry also started facing that kind of thing reflected in that. Now from 2010, we started getting this cloud and IoT and all that stuff. And going forward, we feel that future of this BMS and HVAC field, or whatever we take, even our day-to-day life, it will be only digitalization and Internet of Things and all that. So what we will do in today's thing, we will cover the basic, but the fundamentals have not changed because thermodynamics have not changed, refrigeration cycle have not changed. I'm sure all the professors who are there on this call, they will agree. They will tell the students also, well, whatever you may do with technology, so much of updation may happen, revolution may happen. The fundamentals of fluid flow, vapor compression cycle, thermodynamics, that has not changed. So that will remain same. So while similar to that, the construction of BMS, the fundamental level, the ground level has not changed. So it is always good idea for students, for practitioners who are starting their career, to have a clear understanding of how to build from the base level architecture. And then at the top level, we can always go digital or go give them a simple solution depending on what the owner wants. So now, if we have BMS, we can break it into two parts. One is energy management, that is related to energy. And the other one is non-energy, that is life safety. Because when fire and life safety is coming, we don't talk about energy part. Whereas energy in HVAC system, chiller plant or DX system, VRF system, AHU and VAV control, electrical system, PHE system, lighting control. If it is tenanted building, if we have 10 floors, 5 lakh square feet building, and each floor is occupied by each tenant, how do we do BTU metering? How do you bill chilled water consumption like electricity, tenant billing? All that is very important. And while we also have BMS where fire alarm system is integrated, if you want, we can integrate to some extent access control, CCTV, everything, but it all depends on the cost, whatever we are talking about. So if we see in the background, BMS, it will going deeper into it. It will have this kind of thing. One is HVAC vertical, another is electrical, another is PHE plumbing, another is third-party systems. Now under HVAC we have chillers, air handling units, VAVs, VRF, precision ACs, ventilation. So if you and electrical, you have all this energy metering, elevator, whatever it goes into building. In simple terms, whatever equipment, MEP equipment, mechanical, electrical, plumbing that we have, it can be brought to BMS, by either field control or factory controllers. So like PHE, you take STP, chemical dosing, all those kind of things, and third-party systems. So what is called as third-party is already the intelligence is built in those systems. The fire alarm system, the detectors are there, everything is there. Basement ventilation system, the PLC is there. The pump logic controller is there. It will regulate all the jet fan. But so BMS will not do anything interfere with that control option logic, but it will bring all the data. And if you want to link that data to switch off some AHU, switch on some AHU, or do some other function, it can all be done at the system level, at the higher level. So that is what the BMS does. Through hardwiring software integration, you can integrate the entire building. So the owner, what happens is today they spend a lot of money. You take a building, the rent comes possibly 50 to 70 rupees per square feet, and they invest a lot of money for constructing a building. Maybe hundreds of crores it goes into the building. So when they spend so much money, they want to see and the equipment, whether it is in good condition, because every equipment has got a life of 15 years, 10 to 15 years, or whatever it is. So they want to see the performance, they want to take care of that. So how do we integrate that various equipment? So we have to start putting up architecture for BMS. So that is what is the first step. How do you want to have system architecture? So we have to list down all the equipment at the ground level, unit level. What all equipment we want to integrate. In any building, it may vary. In one building, it may be some equipment. In another building, it may be another equipment. So we have, one is these DDC controllers for air handling units, PHEs, and all data gathering panel. Another is the soft integration. If the buildings have got VAV boxes, then we can bring all the VAV boxes, wire them, and bring them directly. Correct. Then BTU metering if it is there. And if we have DG set energy meters, we can wire them separately and bring it on this backnet Modbus through integrators. For all the third-party devices can be brought to the BMS system and then onto the workstation there. So if we try to understand in a systematic manner, the BMS architecture generally it is followed in the 3 or 4 level. We can say one is the ground level, which is the field or unit level control. Second is we can say automation or system level control, where you have it works as a system, all that together. And the top is the building management, where you see the PC software, whatever is happening inside. அங்க உள்ள என்ன நடக்குது, விஏவி பாக்ஸ்ல என்ன நடக்குது, ஏஹெச்யூல என்ன நடக்குது, சில்லர்ல என்ன நடக்குது, டிஜி செட்ல என்ன நடக்குது, அது தெரியறதுக்கு நம்மளுக்கு பில்டிங் மேனேஜ்மெண்ட் சாஃப்ட்வேர் இருக்கும். ஸோ either it can be in a pad or mobile or software, or going forward it's all is going to be available on digital platform there. Either it can be a virtual machine, or it can be on premises or off premises, all those kind of things we can talk about. But whatever complicated or however big the system is, we can break them into 3 or 4 levels like this and construct the BMS for any building. So now while we do this on the left side, what you see, but going forward, the owner and the digital IT world is going into this kind of thing. Data is there, which means that comes from all the equipment. So we have a lot of information from the data. We can analyze the data, and there is a lot of intelligence and analysis and data analytics which is happening at the top level. So aggregation of data, enterprise management. So we will start hearing this kind of world. But what I want to caution is, we started saying cloud will do everything. No, cloud is not going to do everything. மேகம் என்ன பண்ண போகுது, இப்போ நம்ம பாட்டு தான் பாடணும், மேகம் கருக்குது மழை வர பார்க்குது மாதிரி. If we do properly at ground level, if we do programming, and then cloud is going to do. Cloud is not going to do automatically. Some IT people, some programming people, they have to program the sequence of operation, program the analysis, they should know that basic HVAC strategy. All that can be implemented by the IT. So cloud we will not do unless humans, unless we program it the way we want it. Correct. So let us try to understand and construct a quick BMS system from here. So as you said, these are the 3 levels basically. So the unit level, what is the benefit of unit level? Unit level is basically standalone control. Example solnona, take for example one chiller, water cooled chiller. Water cooled chiller 500 ton or a 600 ton centrifugal chiller with VFD control. What does it do? When you buy a water cooled chiller, it will come with its own compressor, condenser, evaporator. Then it will come with float with the expansion valve, the float valve. It will come with inlet guide vane. It will come with VFD for controlling your compressor. All that. If it is water cooled condenser, if it is air cooled condenser, similar thing. But then it will also come with a lot of microprocessor module. That is, they may call it as compressor module, expansion valve module, condenser fan module, like that. And there will be a master module. And then there may be a touch screen pad where you can go and set my chiller, for example, chilled water leaving temperature. I want design is 7 degrees centigrade. You go and set it at 7 degrees centigrade for one chiller. It will work in an optimum fashion based on the return water temperature, based on the ambient condition, based on your current demand limit set point. It will position the expansion valve. It will position your inlet guide vane if it is centrifugal compressor. All that it will do, it will try to give you 7 degrees at the most energy consuming condition. That is the job of that microprocessor controller, which is sitting on that compressed chiller. So that is a standalone control. But if I have 3 chillers like that, one water cooled chiller, one air cooled chiller, one absorption chiller, for example, in one plant, you can even have like that. Or we have 10 chillers for big building. Then how to control all the 10 chillers? How many chillers should work for my building on Monday, November 25th at 10 o'clock, or March 25th at 2 o'clock, or April or May in the peak summer at 2 o'clock in the afternoon? That small microprocessor controller in one chiller cannot decide. For that, you need a system level controller, which is your chiller plant manager, or the BMS can do the system level controller. So that is the difference between your standalone control and your system level control. What are the things in that unit level control? All the safeties. That is, chiller will work in such a way that tubes will not burst. Your freezing will not happen. Earlier, we used to keep the operating thermostat, antifreeze thermostat, low pressure cutout, high pressure cutout. All that information is going to that microprocessor controller.
Excuse me, Subramaniam sir.
Yeah.
Sir, can you just once come out of the sharing and then again reshare it, sir?
Okay.
Because there are a few people who are having some issue with the visibility. Stop screen sharing and then again share it, sir.
Again share. Okay.
Yes, sir.
Can you see now, Murali Krishna?
No, yes, sir.
Just get a feedback if you want.
Yes, sir. It's visible. Sir, whoever has pinged it in the message, if you can now see the screen, kindly say an S in the chat box, sir.
Okay, now it is okay.
Okay, sir. Thank you, sir. Thank you, sir.
You are not seeing, is it? Okay.
One or two slides, there were a few people having issues, sir. People who are seeing it in maybe through a phone or something like that, sir.
Okay. So now it's visible, not for everyone.
Visible, sir. Perfectly visible, sir.
Okay. Subbu sir, nearly 10 minutes didn't see.
Huh?
Last 10 minutes didn't see.
Getting frozen, huh?
No, Ama. Yes.
Okay. So this is a standalone control. So what does it do? It takes care of the safety on the chiller. That is HPLP cutout, your oil pressure cutout. So many safeties are there. Now for this, I recommend every building automation engineer, every HVAC engineer to learn what are the safeties involved. If you go to Mr. Kaja Modin in his workshop, he will tell you lab training room. What are the safeties required? How to wire them? That has not changed. All this cloud and all is there, but that is okay. But those fundamental safeties have not changed. So though that will still be there in unit level control, whatever complicated system that you are having, alarms, diagnostics. So that is the benefit of unit level control we are talking about. So like that is same for all this kind of equipment. Water cooled chiller is this one. Your package unit, rooftop package unit is this one. Fan coil unit, VAV box. Your again heat pump package unit, your air handling unit with factory mounted control, field mounted control. See, we can even make now AHUs are already available with factory mounted control. That is all the controls you can mount in the factory. When the customer gets everything, they just have to give power, they just have to do control wiring, it will start working on its own. So that is your unit level control for that. Now, how that the controller works. So one is like you will see some arrows going inside to the controller, some arrows going out from the controller. So going inside is the blue color. So which means I have controller. So all these field devices, everything will give information to controller as inputs. We'll see later. Based on the logic which is there, it will give output to all these devices to how to work in what condition, in what position, what should be my position of my actuator and things like that to achieve that set point. Correct? So that is the job of the DDC controller which is there. And typical system architecture is BMS hardware is again you have BMS workstation. All these things will communicate. You have your application specific controller. You can have factory program. For example, VAV box when you buy, the factory itself will set minimum maximum CFM setting. That can be changed at site, but how many things? You have 200, 400 boxes, VAV boxes. It takes a lot of time to change those minimum maximum CFM setting. So that is what designer is supposed to give in that schedule itself, what is minimum maximum CFM setting. So then the factory person will set it and then send it. Then we have IO point counts, DDC controllers. So all this will be the BMS hardware component. So we saw what is this. Now what does the BMS do? So the role of BMS control application, measuring, monitoring, interaction with other building systems. So what is the day-to-day role of BMS? So the most common primary function is the control of building. That is air handling unit should control. That is, imagine that you are in charge of a building operation. You have been asked to switch on, switch off the AHU, maintain its temperature. Whatever you do, BMS is going to do. So how will the BMS do? Because BMS will go and whatever you do mentally, you have to sequence it. You have to write it in a program, flowchart kind of thing. All that you have to transfer it into control logic. First I will do this, second I will do this, third I will. So when we do all that, that is BMS. So that is what we are doing for the air handling unit, VAV box. It will do for chiller plant, cooling tower, tenant chilled water. So which means if we have 20 exhaust fans, 5 cooling towers, 400 VAV box in a building, precision air conditioners, and all those lighting management system. So all that, if we start building from unit level, then from system level and top level, we can make the functioning of all this in an automated fashion. And then it will also do zone temperature monitoring control, zone VAV control, zone CO2 management monitoring control, demand control, ventilation, we'll see. Air handling unit supply air temperature controls, chiller plant sequencing, toilet, car park, kitchen, general exhaust control, all that it will do. So if I take a simple air handling unit, how do you build the DDC controller? You have to draw a schematic like this from the designer. HVAC designer has given you a constant wire. How many filters are there? Chilled water coil is there. If it is an operation theater, you may have a heating coil. You may have HEPA filter. So you draw all this in one schematic diagram, and to get the signal and to automate it, these are the field devices required. So that is how it is required. For example, if I want to know that fan whether it is running or not, I have to put one differential pressure switch, take it as a input, binary input to my controller. If I want to measure the temperature, I have to put a temperature sensor and connect it to BMS. That will tell me what is the temperature sensor, what is the temperature value. If I have the fan, I have to, there will be a starter panel, whether DOL starter, soft starter, or star delta starter. I have to do wiring to that handoff auto switch, all that, and make it automatically working. So how the wiring has to be done with the relays, NONC contacts. So we have to take the wiring diagram and do all that. Motorized valve. Now whether my filter is clean or dirty, I can put a differential pressure switch here and find out whether the filter is clean, means the pressure drop will be less. If the filter is dirty, means pressure drop will be more. because there is resistance to the airflow. Then I can measure that, I can say that the filter is dirty or clean, whether fire is there, alarm is there. If I want to operate the outside air damper, return air humidity. So all these are field devices. It will come to DDC controller. So like this, if you take an AHU, these are the things that you can have. Correct. You can put sensor here. And we have to know from the HVAC designer what exactly is the configuration of the air handling unit. For example, this is an AHU economizer. The meaning of economizer is, if you see here, this is exhaust air, this is fresh air downside, and I am having damper here, motorized damper. I am having motorized damper in the fresh air. I am having motorized damper in the return air. Now, for example, in any location, Bangalore or Hyderabad or Madurai or anywhere, during some time of the day, your ambient condition may be very amenable, very, enthalpy, what we call as enthalpy is heat content. Enthalpy is will be less than your room air for the ambient, which means I can just take my outside air without sending chilled water through cooling coil. I can circulate this air to the room and have comfort condition of 75 degrees Fahrenheit inside. That means I am not spending energy. What I am doing is I am just sending outside air. But for that, what we have to do, we have to have motorized dampers, enthalpy sensor or dry bulb based economizer, and have this exhaust fan, fresh air fan, this supply fan, return fan, and accordingly modulate all this and then supply the air. So these kind of things will come on the AHU controls also. So when we come to this controller, these are the four things which are generally called. One is controllers are built on analog or digital. Now digital, by the mere word, a digital or binary means either it is 0 or 1. It is on or off. Analog means it will have a continuous value. For example, I have temperature sensor. It can sense from minus 10 degrees centigrade to 55 degrees centigrade. So that means that is an analog instrument. And if it is connected to controller, that is coming as an analog input. And if my switch, for example, the differential water pressure, air pressure, differential pressure switch we talked about across filter or fan, based on the fan low side and high side, if I put a fan, there are some bellows there where it will go from NO contact to NC contact, which means I will have a digital input that will give in case that pressure builds from negative pressure to positive pressure of plus 1 inch or plus 2 inch or plus 3 inch static pressure. Analog output is if I want to control valve or if I want to control the VFD speed or something like that. Then the controller will give an output to that VFD. You run at 40 hertz or 35 hertz or something like that. It will instruct. That means it is analog output. If I give an instruction to a compressor or a fan or a pump to start or stop, that means either it is on or off. That means that is a digital output that my controller is giving. So this is how your controllers are built with these four terminologies, which is analog and digital. And these are the field devices examples which will give you analog input or binary input from there, like temperature sensor, pressure sensor. So all these are transducers where it will not only measure the value, it will also give you a value in the corresponding electrical signal. For example, I have a temperature sensor. It can be a thermistor sensor or it can be an analog sensor where it will give you 4 to 20 milliamps or 0 to 10 volt DC. Pressure transducer, it can be static pressure sensor, differential water pressure sensor, duct static pressure sensor, or a pressure transducer across your HEPA filter, or differential water pressure transducer where for controlling your secondary pump VFD speed, I am putting it across the chilled water supply and header, return header, that can be there. Humidity sensor again, that will give you either 0 to 10 volt DC or it will give you 4 to 20 milliamps. CO2 sensor, BTU meters. So that will give over M bus or Modbus or backnet. Level sensor, or I can have a level switch. So there is a difference between a switch and a sensor. Switch means either it will give you only binary. Sensor means it will give you a continuous value. So these are the typical sensors. And for this, we have to use some cabling. So what kind of cabling? One is a signal cable, where we use a twisted and shielded cable, 2 core 1 square mm, which is for this kind of signals and also binary signals. The power cable, in case you want to give UPS power to controller, because you don't want the system to be down in case of a power failure of a transition from normal power to DG power. Then we have to use a power cabling and things like that, and communication cable, because you will be having a lot of DDC controllers. So one should communicate to the other, or they all should communicate to a network switch, because we are talking about these controllers on IP based network, so that they will have IP address and they will be there. So that communication cable is there. Or we can also use nowadays wireless VAV system also has come. There are manufacturers who have come out with systems which can work on wireless sensors, wireless VAV controllers, wireless VAV boxes and all that stuff. So for example, we'll take one air handling unit, typical air handling unit, which we use for VAV air handling units. So this is your graphic screen, what you create in BMS. So this is your return air. This is your connected to the AHU, which is the filter section. This is the chilled water coil section. This is your fan. So this is supplying air to all the VAV boxes. So whatever field devices you have put here, all those things we can get on the graphics. What is my AHU tonnage? Where it is coming from? Because of BTU meter. There is a BTU meter which is coming put on the chilled water line. So from there itself, I can get the tonnage. Then what is my BTU energy value? What is my AHU run hours, static pressure, return air temperature, supply air temperature, AHU fan run status. So all these values we can get for monitoring purpose. And for control, there are some things which are used based on the set point. If I want to control this VHU based on return air or supply air or some other thing, logic, if it is an operation theater, it is separate logic is there. If it is a normal, if it is a pharma application, it may be a different logic. So we have to understand the design intent by the HVAC designer, and then accordingly build this IO point and do it further. Now this is a typical IO point, how you construct an IO point. So whatever I discussed earlier, you put this 4 things, AI, AO, DI, DO in an Excel sheet. You put all the description of IO point, what all you want to do. Like I was telling you, if somebody asks me to go, you are an operator in charge of the building. You have to switch on all the AHUs. You have to control all. What I will do, first I will go and switch it on. Then I will put it in manual mode. Then if it is tripped, I will come to know. If I want to know whether fan is running or not, I will go and check whether my filter is clean or not. What is my supply? I will go and measure it with my sling hygrometer. Then whether my valve is working or not. What is the duct static pressure? So whatever physically we want to know, you put a field device. And that is all BMS. So BMS is not, there is no magic or anything. Whatever that we have in manual sequencing, we all do. If we transfer it to auto mode, you put it all. So if it is a VFD on off, it is a binary output, because it is command means it is from controller to starter to start the motor. So that is an output, which is called a DO. Now after the motor is started, AHU is started, and if it is running, you should know whether it is running. What do? You put an differential pressure switch across this fan. That will tell you whether the fan is working or not. But that will happen only if the handoff auto switch is in auto mode. Because for example, if one mechanic has gone there, something is wrong with the AHU, he is going and inspecting it, he might have put it in manual mode. Then BMS will not do anything. So then I have to take this auto position as a digital input from a potential free contact from the MCC panel. So the wiring has to be different. So if we are buying the starter panel from somebody, if they normally supply for a standard job without BMS, when there is a BMS on another project, then they have the starter panel will have to have all these NONC contacts, additional relays, everything, and the wiring has to be done for BMS application. So this is important that we should know, and that is to be taken care of. Then filter status will come as this. Supply and return air. This is analog. So this is coming as an input to the DDC controller. So this is input. Chilled water control. So whatever is control will go as output, analog output. Feedback, my valve, I want to know what is the position that is coming here. That static pressure sensor, this one. VFD speed control output. Bypass is digital input. Power on status. Like that you join together. You add them. You are getting, for example, here including spare 5, 3, 7, 2. 5 analog input, 3 analog output, 7 digital input, 2 digital output. So you size your controller based on this. So this is how you build your controllers from every location. You have to build your controller. Then what is VAV? VAV is basically a box which will give you localized temperature control for any cabin or any localized control for that. For example, there are 3 cabins. You have your VAV. You can put your temperature sensor, and then accordingly the damper. There is a controller on the VAV box. It is going to take care of that position. So, for example, you are having a small VAV in a centralized location here. So this is what is going to happen. You are having 3. You are having the AHU supplying air to all the VAV boxes, and then each VAV has got its own temperature control. What is the responsibility of the AHU? The designer has told, my supplier temperature to all the VAVs is constant. That is 16 degrees or 15 degrees or 17 degrees. After that, the VAV's job, the sensor and the controller job is to take care of that particular cabin temperature based on the set point. For example, Tirunavakarasu may set it at 22 degrees. Now, Satish may want 20 degrees. Dr. Kumara Gurubaran may want higher temperature. So each damper set point may be different. Accordingly, the damper position will vary. The controller will work on a pressure independent controller. It is always good to use pressure independent controller on the VAV box. And there is a duct static pressure sensor based on which, because one damper may be 20% open, another will be 60% open, another 90% open. So you, based on this, then this pressure will build up in the duct. Based on that, you are reducing the fan speed. And that is where the energy saving comes. And the fan speed, when you are reducing the fan speed by 50%, for example, your energy consumption is cubed. It will get cubed. For example, 0.5, if your speed is getting reduced by 0.5, your energy consumption is 0.5 into 0.5 into 0.5. That is 0.125, 12.5% for a 50% reduction in speed. So this is as per the fan law, which you have learned in fluid mechanics. So this is where whatever you have learned in your college, that is will come handy for finding out energy calculation, energy saving. If somebody is becoming an energy auditor, all this will be useful in that calculation part. Now, fresh air is something which is demand control ventilation. Like, for example, you will find in this drawing that in this slide, people in different floors, number of people are different. For example, here, initially when designing, we will design with 100% design occupancy. But 100% people may not be there in that particular. Here, for example, only 4 people are there where I have designed with 10. So my fresh air requirement is only for 4, not for the entire 100. If I keep on pumping for all the 10 people or 100 people, then my energy consumption at the AHU will be very high. So that is why ASHRAE standard 90.1 talks about demand control ventilation. So how do? I have to put CO2 sensor, because if 4 people are there, my CO2 output will be very less. Not like 10 people, like in a cinema theater, no, if 400 people are there, your CO2 level is going to go high. If there are only 10 people during COVID time, you may not get CO2 level, which is very high. So you don't have to supply that much. So ASHRAE standard 62.1 and 90.1, those are very good guidelines for fresh air calculation and energy saving logics, what is to be followed there. So this is demand control ventilation, which is required from BMS. Now this is something which is on the, how do you build IO point for water side, chilled water side and pump chiller plant. So what you see here in this drawing is chillers. There are 3 chillers. There are primary pumps here, 1, 2, 3, 4. Then there are secondary pumps here. So on the bottom, you see DDC controller. You will find AI, BI, DI, AI, BI, BO, AO, like that. So like similar to the logic what we said before, we will have, output valve, motorized valve at the chiller output. So for this, we have to follow that logic, build the controller based on my BI, digital input, digital output, analog input, and analog output there. Then that is in a summary for you for unit level control. Now coming to system level control. System level control is what I told you about the chiller plant. For example, if you have 3 chillers, 4 chillers, 5 chillers in a plant, how many chillers have to run, how many pumps have to run, that is something which is a system level control has to decide. Or a fan pressure optimization also, some of the vendors have got a software where they can monitor the damper position and duct static pressure. And actually 90.1 talks about resetting that set point also to achieve energy saving without compromising on cooling also. So that is again, that is there one. Then chiller plant management is something which is an important thing in our BMS control. So we have the meter is on the building, because as you know, the percentage of saving comes from chiller plant. It's almost 50 to 60% in HVAC there. So the graphic screen should depict whatever is installed, the way it is piped in the system at site. So you have chillers, you have primary pumps, you have secondary pumps, a decoupler line here, and cooling towers, condenser water pumps, and all that stuff there, right? So the constant flow, see, this is a constant flow system because you are having 3-way valve in the AHS. For example, healthcare, hospitals mostly follow the 3-way valve system, right? So 3-way valve system means constant flow, which means whether out of 3 chillers, for example, even if I switch off one chiller, all the 3 pumps have to work. That is important. So that is control is a different method. You will have to reset the chill water leaving temperature of operating chiller to get my mixed temperature as per design and run all this, so that I will not compromise on chilled water flow requirement at the last AHU. This has been the problem before the primary secondary came. Now when we have primary secondary system, those problems are all sorted out, because you are decoupling the production of chilled water and demand of chilled water. The top side is, you are producing chilled water with primary pumps attached to chiller. The secondary pump, distribution pumps or with VFDs, which go to the system there. And there is a bypass line where there is no valve. Chilled water can flow either in left to right or right to left based on the difference between primary flow and secondary flow. So here you control based on the chillers are controlled based on the leaving chilled water supply temperature, and the subtraction of chillers are controlled based on the delta T of that. That's what we will see here. For example, there are 5 chillers in a building. My set point at the header line to the air handling unit is 45 degrees Fahrenheit. There are, for example, in the month of May at 9 o'clock in the morning or 10 o'clock, one chiller is running. As sun start coming, people start getting occupied, the chilled water temperature goes up. When do we add one more chiller? So this is my chiller temperature, it keeps on going up. Now, if it is there for a long time, sufficiently long time, either 5 minutes or 10 minutes, or adjustable, then you add the chiller. Once you add one more chiller and primary pump, then the temperature comes down. So this operation will keep on continuing for every chiller. So this is the addition of chiller. And for subtraction of chiller, you do based on the delta T between the supply and the return water temperature. This is one of the good methods of doing subtraction of addition of chilled water, and that will take care of energy saving on the chiller plant. Variable primary flow, the same thing like before, you will not find the secondary pump, but the VFDs have shifted from secondary pump to primary pump. And what is the other thing we find here is flows. The measurement is very important in variable primary flow. What are the advantages of variable primary flow? Your number of pumps are less, your electricals will be less, and your only thing is your control logic has to be very good. Otherwise, we will be damaging the compressed chiller, because what happens is we are varying the flow through chiller, and with every chiller manufacturer, there is a rate of chilled water flow. They do not want that to go below a certain value. So we have to take care. If we go below that, the evaporator tube will burst. Then water will go into the compressor and from the evaporator, and then we will have a problem with the compressor refrigeration cycle there. And we have to have flow measurement, And in the decoupler line, you will see modulating bypass valve. So this is topic we can take as one separate day if you want. We can take it for half an hour to 45 minutes on how exactly this variable primary flow and this primary secondary system, how it works. Maybe we can have one separate session on that if you want. So we can have different size chiller. If your capacity is varying from 200 to 1200 ton for a building, it's not that we have to put a 400 ton chiller of three chillers. We can put two of 500, one of 200. One can, and then operate based on the load requirement. We can operate the chillers based on that. And you raise chill water leaving set point, you get an energy saving there. So these are the advantages of your chiller plant control. It determines the load, capacity matching, runtime equalization, failure recovery, and we can do complex algorithm. Reports are available, and chiller dashboards we can see from BMS. How exactly we want to do from there. So going forward on the protocol. What happens is the BMS is going to interface with a lot of other systems also, fire, security, access, lighting again. So you will have various things at the ground level, then they all get integrated. Okay. So protocols, when we talk about BACnet, LAN or Modbus. These are the three common protocols. So what is BACnet? What is Modbus? What is LAN? We will see. So these are like controllers can be with the BACnet controller. So when we get a controller, it's not the manufacturer which is important. We can buy from X manufacturer. Second, after 3 years, we want to replace some controller. We can buy that from somebody else also. We don't have dependency, right? Owner is not locked to one supplier, one vendor. So that is the advantage of having an open system architecture. So we follow BACnet at the system level. And at the unit level, either LAN or BACnet over IP. So why is it important? Because in a system, in a building, you will have all this equipment, elevator, lighting control system, for example, because going forward, every building will be a smart building. Now you have HVAC, you have access control, you have CCTV, security, fire, life safety. Now suppose there is a fire safety, there is a smoke alarm sensor, it is giving an alarm in one place. So what are the actions that the building has to take? So you have to recall the elevators because you don't want people to use the elevator. The lighting has to be on. The smoke control has to get activated because you want to stop all the AHUs. You don't want to spread the fire by keeping the AHU on. Now voice evacuation has to call. The access control has to unlock. Now video surveillance, because you want to start recording where the fire came, or is there any problem with people running to the ground level, security alert. So all this is communication. You want to share the information from one system to other systems. How is it possible? That is possible only by interoperability, where you are exchanging information from one system to another system. That is where your BACnet becomes important. What is BACnet? ASHRAE standard is Building Automation Control Network Standard. So this standard is basically, it's a protocol which is there written by ASHRAE, and possibly I think 2019 or so is the latest one. So it is basically a data transfer. It defines what exactly, how do we define analog object? How do we define binary object? So that is almost a big book of some 300, 400, 500 pages, which is there. So if any manufacturer wants to start manufacturing a product, or a system designer wants to install BACnet, all that information is available in this standard. Then LAN is another protocol. Neuron chip is there embedded. On that, there is a neuron ID it will have on the device. For example, we buy a precision air conditioner from Emerson or AP or somebody else. If we buy this with the LAN protocol, which means I can connect a wire and get my information to my BMS if it is LAN compatible. So what is at the brief level is there are profiles available. There is snippet profile. We talk it as standard network variable profile. So it talks about temperature, pressure. They define the unit also, so that Tomorrow we don't have to, we are not in dark, whether what information I will get from that equipment, apart from its own standalone safety, which we talked about in unit control, so that the profile is defined. Okay. Then Modbus is another protocol, which is a de facto standard, which is there for all major electrical equipment, VFDs, power monitoring, energy meters, transformers, DG sets, UPS, precision air conditioners, lighting control panel. So by this, we can get the parameter. So there are integrators available which will take this information on BACnet Modbus and it will convert to BACnet and for that the system level for us. So then what we are talking about is we discussed on the unit level, we discussed on the system level, going to the building management level. What exactly the building management does? This is what an operator will see on the screen. See, why is this required? Because that operator, he or she may not be an HVAC expert. Their expertise may be electrical, maybe an electrical engineer or or somebody else. But for them, we have to give information in a simple manner because the complex programs can run behind. For example, a hospital we are doing, suddenly, some nurse station, they may see whether unit is tripped or OT fan, for example, AHU is not. So it has to give some information on the graphics in a way in which everybody will understand. So this is graphical user dashboard, real-time monitoring, trending logging, all the values, temperatures, we can do logging, time scheduling. We can do the time scheduling using the time clock with there, fault management, control application, energy management reporting. So all that can be done in the graphic screen. So these are some of the dashboards that we can create in BMS. Once we have all the IO points wired, the systems programmed, graphics done as per our requirement for each and every job, we can do that part. So these are some sample graphics. This is like 2 air handling units supplying for one build space, some 30,000-40,000 square feet. We can get the tonnage, which is because of 1 BTU meter is there in the line. All these values we can see there. Then this is the summary screen. That is, you have multiple air handling unit, put all this thing. So if the operator comes and opens the screen, they will know where the problem is. Which air handling unit is having some tripping problem, or my temperature is not coming, or my valve actuator is not working. So this is like doctor seeing 100 patients. He may not have time to go and see every patient, but he will ask, he will have a dashboard where he will see important, what is the blood pressure value for everyone, what is the sugar value for everyone. Then he will give attention only to place where the patient is out of control. So it is like that kind of a dashboard scene what we are talking about here. So VAV summary screen, if you are having variable value VAV boxes, we can get summary screen. Then we can also get VAV occupancy. The AutoCAD layout can be put, we can map that so that at that particular room, what is the temperature there and what is my temperature distribution. As the temperature goes higher, the color can change. So all that facilities are available. Now, what is my lighting management screen, map screen we are having. So this is the DDC enclosure box which I talked about. So your DDC controllers are going to come inside. There will be a transformer which will give 24 volt AC DC power supply, and then it will all the terminations, all your NONC contact relays and all will be mounted here for binary output. So if you want to become a BMS engineer, if you want to expand, you should get to know all good electrical wiring. Electrical is very important thing which we should know, and people can start manufacturing these panels, it's a good field where entrepreneurs can do a lot of expansion of their business. So water leak detection for data centers, a rodent system, where there are problem with the rodent, then tenant comfort. So these are some kind of alarms. So we can get alarm because we want critical alarm. Even if we are on a holiday, you are manager of the building, you want to get some remote alarm, that is possible, correct? And what are the energy management things? If owner will ask, what will I get from energy management? So optimal start stop of building, building warm-up, cool-down cycle. We will know, we can better manage the building. If it is a hospital or a hotel, these are all will be very important. Seasonal temperature adjustment, economy cycle, equipment runtime. For maintenance purpose, if there are 5 chillers, we can run it in such a way that all are run equally. And this is one sample dashboard for the entire, for example, one BMS screen. So BMS dashboard, if the operator comes and opens the screen, he can get to know what is my cooling load, what is my tank water level, what is my DG tank level in the building, whether which day fuel tank, do I have day fuel for 1 day, or is there one tank which is having problem? How many chillers are running, what is my chilled water set point, what is the leaving temperature. For example, here 7.7 degrees is set point, 7.6 degrees is leaving temperature. What is my chiller capacity? It is running at 62.7%. Why? Because ambient temperature is only 24.7. You see on the right hand top corner of the screen. So it is able to, and from here we can find out, what is the, once you go in detail, then we can get to know all the parameters of the chiller. That is what we are going to see later. Then we can find out all that kind of information. But today's challenges is building operation. Owner wants, centralized operation and control, right? I will just quickly take you through this one. Maybe I hope I can take some 10-15 minutes extra. Is it okay?
Sir, not an issue, sir. You can, sir.
Okay. So,
sir, we are having a full house of 100 people, and
yes,
you are engaging them. So there is no, you can take even another 15 minutes or 30 minutes, sir. It's up to you.
Okay. Thank you. See, we talked about so much on, that chiller when we buy, we are getting this leaving temperature, entering temperature, so many things. So what do we use? What do we do with this data? Data is there, but what do we do with this data? For example, I'm just taking one example. We can do the same thing with other equipment and other information also. For example, I'm just taking chiller and chiller plant. What is the important thing? If you ask Mr. Kaja Modi, he will tell you approach temperature. If I see that value, I will know whether my chiller is working fine or not. It is like doctor checking, blood pressure and sugar value. He will tell you, get that tested and come. I will tell you whether you are in good condition. So discharge and suction temperature and pressure. Chilled water leaving temperature versus loading was a set point. What is the set point? What is my temperature? What is my entering and leaving temperature? And all those kind of things. And for subsystem, primary, secondary, variable primary flow, chiller tower optimization, storage. So for example, when you go and click in the chiller graphics, one chiller you go and click, you will get all the details of the chiller. For example, you will know what is my percentage load on this chiller. It is a 450 ton helical rotary screw chiller. 77% it is running. Leaving chilled water set point is 6 degrees. Leaving chilled water is 7 degrees, which means, it is, since it is loaded only 77%, it is still 7. Maybe another 10-15 minutes, I may get 6 degrees centigrade. What is my entering temperature? 12 degrees. Leaving condenser water 31. Entering 27. Condenser approach is 4 degrees centigrade. This means this is little alarm. Because if your approach is more, what is the approach? My leaving condenser water temperature and my refrigeration condensing saturation temperature. Because that temperature, if it is more, that means my heat transfer is not efficient, which means I am losing energy there. So which means you will have to start doing descaling. You will have to do chemical descaling and all those kind of things there. Evaporator approach, chiller run hours, compressor number of starts, because this is chiller technician will come and see whether my starts and start ratio and run hours are equal. Because if you have got too many starts, you are going to have problem with that winding of that compressor motor, right? Then what is my guide vane? Actually, it is a centrifugal compressor, chiller, because we are having guide vane. Actual guide vane position 24%, oil temperature, demand limit. Suppose you are having a problem with your transformer and you can't take more than 70% current, we can do current demand limiting set point. so that chiller will not take more than whatever you are setting it. There is manually you can set it in the touch screen pad of the chiller, or from BMS you can go and set it from BMS also. Compressor thrust bearing temperature. So chiller manufacturer gives all this value. It's all coming there. But so we have to have a threshold value for all this. Some critical things we should put it as alarm. If it goes beyond that value, it will give alarm to the operator. Correct? Then similarly, we have air-cooled chiller. What are all the values? This is, set point is 7.2, leaving is 7.8. So the chiller technician will come and see all these values and see whether my expansion valve position is correct, my compressor capacity is okay, all that kind of information. There are a host of 25-30 parameters are there, which we have integrated through BACnet. Through BACnet, we are integrating, getting all the parameter by using one pair of twisted shielded wire of 2 core 1.5 square mm. You get all this information from the equipment to the BMS screen, and this is how the graphics will look like. This is how the entire parameters also are going to look like. And from here you can change the set point, chilled water set point, on off demand command, and current limit set point also you can change from here. See, it will be useful for everyone, because you will know, because some of you may be taking operations contract for building, or a BMS contract for either operations contract or maintenance contract. So we should be very familiar with all this operation, what you can do with BMS, so that you can add value to the owner for that. So this is the kind of chiller dashboard which we can make. Look at one screen can give you multiple values there. And this is the graphic screen which we can create, which is very important for the operator. What all parameters, what all equipment are there, whether it is working. For example, I have motorized valve at the evaporator outlet, chilled water evaporator outlet. If I have primary, secondary system, sometimes the actuator may be faulty. It will be in open position, it will tell me close. It may be in closed position, it will tell me open. So we have to check all this physically and see whether in graphics it is correct or wrong for all our operations purpose. Then cooling tower VFD. Through Modbus, we get all this data. What is my frequency? It is running at 34 Hertz. My voltage is this, power is this, energy is this, speed is this, run hours is this. So by integration, we get all this value. By secondary pump, my pressure value set point is 1.4 bar and actual value is 0.9, which means it will reduce it. My valves are closed, which means the less chilled water flow is required. So what will happen? The PLC will start reducing the VFD speed. You have to see whether it is happening even over 5 minutes, 10 minutes, 15 minutes. If that does not happen, we have to call that secondary pump PLC vendor and ask him to check his programming. And most often what we will have, when we commission and hand over the building will not be 100% occupied. And that time, if they commission, the set point values will be different. So what we need to do, after the 100% occupancy of the building is there, we have to revisit all this set point commissioning, and we have to do recommissioning of the building. And we have to tell the owner, see, look, I have done my job, whatever contract you have given me, but it is not my fault that your occupancy is not there. So after it comes, we will have to recommission after 6 months. And for that, let them pay the money also. No, there is no issue. You can tell them upfront, and then you can get some work also. And Ashray, you have got a lot of this commissioning guideline are there. We have Ishray also has come up with the commissioning standard, actually, right? So utilization of analysis of data is important for performance improvement. So that is where performance improvement of the machine is, we are talking about on that. So then analysis of data, we can always compare figures of month to month, year to year. This day, last month, how much was it? This day, last year, how much was it? Am I consuming more power, less power? For example, my kilowatt per ton for the whole system, is it less? Is it more? What is my kilowatt per ton? When should I change my chiller, which is 10 years old or 12, 15 years old, right? So all that information is possible. from here we can go to this one, which is, for example, what do we get from BMS? These are the values we can get from the BMS screen. At the front screen, it can give you a snapshot of what is my power consumption in the building. 8.8 megawatt, correct? So what was my installed power consumption, installed megawatt? Maybe it is 10 or 12. So I know that I am not exceeding, or I am fully, I am reaching my threshold value. What is my energy consumption? What is my cooling energy consumption? What is my energy performance indicator? Ambient temperature, ambient humidity. So I can get all this, so that, and this will be, owner will be proud. Okay, I know that the equipment is running well. Suppose imagine the owner has got 10 buildings across Madurai, Trichy, Chennai, so many hospitals at so many places. If he gets all this information, and if you are able to provide as a service provider, as an operations contractor, or a BMS contractor, then he or she will be happy that, yes, I know that these are the assets for me. These are working in good condition, and he will know when to change the equipment. So these are the energy meter values which are coming through Modbus integration, for example. And in the graphics itself, you can create, innovatively, how, like a screen window, you can put kilowatt hour, it will keep on changing. And where is it located? It is located here in this location. So we can, the graphics is a creative thing, which depends on that particular programming and graphics person. So you can always, create your own graphics with values there, so that it will add some kind of value to the owner there. These are the kind of trended value. If I am monitoring the energy, you will know that how, suddenly in 12 o'clock, the energy value is more. Now, if suddenly, there is some wrong information or something else is happening, you will know what is there. And my energy between different systems, IDF, HVAC, lighting management, we can see the distribution of energy between AHU, lighting, and my data center. So many things we can see that also by monitoring the value. Main incoming energy consumption analysis. This is incoming 1, incomer 2. Now, if I analyze this over 1 month, which means incomer 1 is, consuming more, incomer 2 is consuming, it is, the load is less on that. Is there a reason for that? Is there anything, there is a problem with incomer 2? All that kind of analysis can happen from BMS. And this is your LT energy consumption, for all your different things. Chiller panel, kitchen, fire panel, utility panel, we can get that value. And what is your hourly load analysis? Daily maximum load, when am I getting, where am I getting the average load? That is, the tonnage I can get. Energy, lighting energy consumption. What is my AHU load and chiller capacity? Suppose I have designed for a building 1050 tons, 1500 tons. But I am not at all consuming 1500 throughout the whole 1 year for 3 years, which means 2 chillers are enough rather than 3 chillers. We can take out 1 chiller and put it somewhere else. That kind of information also, decision we can take from BMS. And this is a DG set, for example. We have 3 DG sets. So if you see here, 3rd 2017, the DG 1 and 2, they have worked equal run hours, but the DG 3 has not run. It has run only half of DG 1, which means there is some problem with that DG. We have paid the same money the owner has paid, but there is some problem with it, because of which the operator is not running it. So we can fix the problem, why it is happening, so that equal run hours means equal wear and tear, equal maintenance for all the DG sets. I think this is on the graphics part. We can go back to this screen. I think we had 1 minute. I will go back to this screen where we left actually. Yeah, I think this is where we left. Why we left here was, see, today in any building you take, there can be a facility manager, there is a maintenance people, building owner, the building occupant may be different, tenant is Tenant is different. Tenant means, we are talking about the entire floor. Occupant means that particular person who is sitting in that office. Energy manager, there may be there. Each one's requirement is different. If I ask a chiller person, he will say my chillers have to work well. A facility manager, he doesn't want to have problem. Building owner wants to have saving on operating cost. Building occupant wants proper temperature and humidity and fresh air and indoor air quality. So each one's requirement is different. So that is all possible by properly getting data, analyzing it, reporting it, and wherever we want to take actionable information, we want to take corrective action, we have to do all that from this purpose. And for that, you have to analyze the data. You have to do, if it is HVAC system or MEP system, and then we have to do. So we have, the new systems, we have key performance indicator cards are available. If I have multiple chillers at multiple location, what is my kilowatt per ton, which is not performing, where I have my boiler, where I have lifts, what is the problem, DG set. So we can get these kind of nice dashboard screens collecting data from the system. Now today, I think from here, we will just see a little bit on the IoT part, right? Now, IoT is Internet of Things. What is Internet of Things? Definition, if you see, it's a system of interrelated computing devices, mechanical or digital machines, objects, animals, or people that are provided with unique identifiers, ability to transfer data over a network without requiring human to human. Now, why is this important? Because if you see this screen, today's world, volume of data coming in is very high, right? Even you will know also, earlier days, we used to log the data. If you have a chiller plant, we will log a chiller leaving temperature for every day, every 1 hour. Now, where do you keep that book? What do you do with the data? What is the purpose of that? But today, it's all coming in digital format. So for that also consumes space. It consumes gigabytes of data. So what do we do with that? And the speed with which it is coming also is high, and variety value is more, right? So that way it is not going to be that great. 1 minute, I will just see whether I have one more. Yeah. So we have variety of data because building systems, protocols are different, volume is more, velocity, the speed at which data is coming is also high. And if we go by IoT, these are the IT companies which give different, terminology, different meaning to this IoT. One person calls it as wireless connectivity to things. Another person gives a long information. But basically it is, for example, if I want to measure temperature, I don't have to do, physically connect it also, or I don't have to go through a DDC controller. It can sit on the system level itself directly, or it can be wireless. So that is the meaning of that. Like Accenture calls it as Internet of Everything, is connects physical world to the internet, right? And today you have various systems connected to the building, renewable energy, IT power and all that. And I think the focus has shifted from products to solution. Nobody wants to be interested in, what is the product that you're selling? What is the solution that we are giving as this one? System architecture, earlier it was different. Like what we saw, unit level, the heaviness was in the down, and the top one was light. But going forward, the present also is like that only. But going forward, the future architecture, you see a lot of things happening on the top. which is the BMS, building management level, everything is happening on the cloud. And while this is all there, but this is also the top part also is gathering more information. So even we can see in the news also, and all the education institutions, everyone will be knowing. We are talking about artificial intelligence. We are talking about machine learning and so many things. In our field also, it has started picking up a lot of momentum, lot of speed, and it is good to get more and more capability at that level also for our benefit actually. So how does that happen? So we are having this information. We have the existing system. Existing system will be same. There is no difference actually. But what we have is we have the communication. The protocol is going to be different, because what we are having is we are following that MQTT protocol, which is which is the method which we are using. It's a lightweight protocol we are talking about, which is transferring the data of information to the cloud through that protocol, right? So that is message queuing, telemetry transport. This is what the IT industry is using. Now that is why we see a lot of this Cisco's and other companies talking about IoT, because they have gone far ahead, and maybe we have to catch up with them. And then our part, HVAC, we should not lose to their way. We should still keep tab on that. So existing building, what do? We can put a gateway which will transfer from backnet over to the cloud protocol, MQTT protocol, and take it to cloud and process the data. So today, what do we have? Today we have different locations. We have the existing in backnet over IP. The information is coming from that. So on top of that, we put gateway. And today, what are we doing at the cloud level? The Microsoft is having that Azure. Amazon is having that Amazon AWS, and Google is having Google Cloud. So all these are, we can pay for per data point. We can pay, and they can process the data, and then they can give information to the owner that corrective action we will give you every 1 month, every 15 days, every 1 week, and then the corrective action can be taken by your facility team. So these are the IoT cloud platform providers. Application is offered via cloud platform. For BMS application, energy management, analytics, fault detection, diagnostics, maintenance management there. And we can that way. How do? We can possibly have virtual servers. We can move away from physical servers to virtual servers and do that also. So space utilization platforms can be there. So this is the same thing which we saw before. So the fault detections and diagnostics, the software, that is also gaining a lot of ground. It's an analytical tool that identifies faults in HVAC, electrical, lighting, and provides advice about how to address those problems there. That one. So, for example, this is augmented reality is again something which is another thing which has come. So, without physically connecting any wiring to the controllers or any device, we can find out what is the problem with any controller, what is the thing there. So, for example, I have a short video. Maybe we can just run it. So this is one augmented reality from one of the companies, so what they have prepared. So these are the controllers which are wired there by this company, but obviously maybe there is some problem with some controller. So how you do it with the augmented reality is find out what it does is you are able to scan it without any connectivity, without any hardware connectivity. It will spot out what is the DDC type, what is the model. It will tell you the serial number and all that stuff, where it is located in which building, right? And then what kind of problem that we are having with that controller. It is just a small video for 1 minute. Maybe it may be useful for some, just to go ahead. It's augmented reality thing. So it will fetch the data. It will tell you what is the manufacturer name, what is the serial number, what is the software version, and all that stuff. And out of that, which one is having a problem again. So it is just scanning all those channels, and which is having, which wire, which protocol, what is wired. It is LAN network, it is a digital input, all that stuff. And this is what some of the vendors also, showed it in some ACREX platform, and maybe we'll try to get some of them in Bangalore again in the ACREX. So this is like in one machine there is some problem, one controller, some AI is not working, input is off, channel 1 is off. So without physically connecting, we can do a lot of thing with this kind of setup. Now, going forward, then we are having smart actuators, smart sensors. That is what we talked about. So from earlier, getting connected to DDCs, we are moving away to smart sensors, smart actuators. Those kind of systems also are happening. For example, smart actuator, it can give you integrated control application, local trend storage, local calendar, and through app you can see everything. But while we do that, we have to know what is the basic application of that. What does it do? That fundamentals have not changed. That is where I told you the fundamentals have not changed. I think almost we are at the end of the presentation. I just want to share this small slide. We used to have, 1914, some Ford, I think, started the car. There was no dashboard. We don't know what speed it is running, how much is my fuel level, all that stuff. But today cars are having this kind of thing. Why not buildings? And and we are having equipment which is a VRF or a split system or chiller plant, chillers, all with very good microprocessor controls. So why not we put BMS for each building, be it Madurai, Tirunelveli or Trichy or Ramanathapuram? Why shouldn't BMS be there? And why not, we educate the owners? Yes, you can buy car with all this, but why not buildings also with, good digital system, right? So I think that's the summary. What does BMS do? It helps control and monitor all assets, because this is a good asset for owner. It's crores of money he's spending, he or she. It's a helpful tool in the hands of facility manager. It improves operational response and efficiency, right? And helps owner to reduce energy bills, enhances life cycle of the equipment. Multiple sites can be monitored, controlled from a single remote source. And going forward, IoT cloud connectivity is catching up. We need to get trained. We need to get ourselves, more aware about it and know how those systems are put together. But basics of BMS is core connectivity, which is there remaining as it is. So we can take some questions, and those are the things which I have put together.
Thank you for a wonderful presentation, sir. Now the session is open for questions.
Yes,
Yes, additionally,
sorry if I've taken more time, Rajiv.
No problem, sir. It was all informative. So thank you for your experience, and thank you for the advancement that is happening in, you have updated us with all the advancement in BMS, sir. Thank you.
Yeah, thanks. Thank you.
sir, in one of the slides, the duct static pressure sensor is shown in the discharge of the fan. Whether it is recommended to install discharge of the fan, sir?
Yeah, see, sometimes what they do, there are some manufacturers who are able, if you have got a VAV is also connected to the same BMS, what they say, we can put it on the discharge, and then they can, not in the plenum, but in the duct actually, then they can see this value and also the VAV damper position, and then take corrective action. Otherwise, as I think what normally we do, 2/3 down the line, we put it in the correct location and do. That is a good practice. But some manufacturers, they are able to give a VAV entire control system, some manufacturers.
Okay.
So in that case, we can possibly look at that, but not all the installations.
Thank you, sir. Thank you.
Any other question from the audience? So then I'll put a small like idea, like probably our industry is going to become a combination. We need to know everything, like from electrical to HVAC to plumbing. Like we need to know end to end the solution. Only then we will be able to integrate, and also we will be able to support the whole system of what the customer needs. Maybe 5 years down the lane or 10 years down the lane, what we can see is like the industry is going to become as Uday Kumar sir always says, he uses a word called trans. It's like it's not enough if you just know your industry or your technicality, but also you need to understand the other people's technicality. So we are moving towards that segment of the industry. So but what do you think about this, maybe 5 years down the lane, as per your the whole content, installing the field devices is very critical for generating the whole data that we are actually whatever we are seeing it in the dashboard. And the knowledge gap is something which is going to grow very large at the field level, and the technology is going to as you are rightly said, like cloud is not going to solve our problem, but they are going to take over this industry for some time, at least 5 years down the lane or 10 years down the lane. So how, as an industry, as an industry expert or 39 years of experience, how do you see this industry is going to move actually? Because after some time, I what you are saying, like maybe IT industry will start dominating all these industries. Maybe MEP will be dominated by IT industry. Is that going to happen, sir?
That is what is happening, Rajiv. Now, see what is happening now. Whatever the hard work we do, we put it in chillers and chiller plant, all that HVAC. Those IT people will come and sit, as if cloud will do everything. They will come and say, IT data crunching, all that will talk, and there will be 4 or 5 companies, they will start doing the cloud. They are already started doing, and they will start. I'm not sorry for using the word. They will start getting compensated much more than the hard work that all of us are putting in our field. So now, if we want to catch up with that, each one of us should know about all this quickly and start educating customers. Yes, we know it. We know what is talking about. We can manage your building with for HVAC or MEP DMS much better than that IT people. The IT is only connecting information and doing that at the cloud level. But the core expertise is all only with all of us. Like for example, doctors, you can do the operations still are done by doctors only. The technology may be very different. The way they do it may be different, but still they are still keeping it all to them. So like that, we also should catch up with this system and start educating our customers. So many things are there. We know about it, and if we provide value to them, they will definitely go for it. Otherwise, we will lose our grip, and then they will start dominating.
Agreed, sir.
Hifasuddin Taj has raised a hand.
Yes, sir.
Hello. It was an excellent program, sir. It's like eye-opening, and it's refreshing for me. That shows the BMS is so crucial for an building owner or a property owner, as well as the scope, what is available. It's really eye-opener for everyone. Thank you so much for your wonderful presentation. I have 2 questions, sir. I think I will make it. Sir, as far as you have mentioned BMS, is that limited to only for chiller plants? What about VRF and ductable individual units? Is that can be integrated into BMS system?
Yes.
Number one.
VRF also we can do that immediately. Okay, you will hear the second one also, then I will answer.
Okay. And the second one is, as far as CO2 sensor is concerned, sir, what I am saying is, like, if the CO2 error or the higher level is being mentioned, the damper will be opened and the fresh air will be flown in, okay? And in that may, if it is a hot place, like where I am, that will increase the energy level. How we are going to handle it?
Yes. So the first question is what you said is VRF. Yes. I put it in on that slide. VRF system also can be seamlessly integrated like chiller. So VRF your microprocessor will do VRF control. The BMS will not go and tamper with it because your manufacturer's warranty, the VRF safety of the system will not be interfered. But at the same time, BMS can monitor the data of your 100 indoor unit, 5 outdoor unit. It can get all the parameters through backnet over IP. And those information is available with every VRF manufacturer they are having, because today they know that BMS is very important. We have done jobs with major companies like Salesforce International and so many people. We are getting all that VRF data, right? And the second question is about your CO2 sensor. Yes, in a place like Ramanathapuram, where that's why I told cited example of Hyderabad or Bangalore or Delhi, because where that enthalpy content, that is heat content, enthalpy value, because of your humidity, your either temperature or humidity, we have to understand by psychrometry that is will bring the load on the machine. So there we may not be able to take advantage. But in a place like Bangalore or Hyderabad or Delhi or Nagpur, we can do that part. Right?
Okay.
So that's why you are putting an enthalpy sensor or a dry bulb sensor. In a place like yours, we cannot put enthalpy sensor. No point wasting money there.
Oh, okay. Thank you very much, sir. That and also, excuse me, everyone. If anyone have any renewals, please do it as early as possible, and please refer. You will get a lot of information from Vishek. Thank you. Signing off.
Thank you, Fazuddin sir.
Thank you, Rajiv. Trust everyone. Whatever I've shared, and we can do a separate session on chiller plant variable primary flow and primary variable flow and primary secondary system. So that's a separate 1 hour subject.
Sure, sir.
We can go through that on a separate day.
Yes, sir.
Subbu sir.
Yes, Tirunavankar sir.
Very thank you. Very informative session. It should be physically. It is more. It will be useful to Madurai members also.
Yes. Always for Madurai. We will do special program for Madurai.
Thanks a lot. Thanks for your wonderful session.
Thank you, sir.
Sir, we will try to arrange it, sir.
Yes,
Thank you for your feedback.
Thank you, Doctor. And you have, great academicians there, Dr. Sridhar.
Thank you, sir. Sridhar.
Uday Kumar, Dr. Kumara Gurubaran, everybody is there. So, it's so nice.
Sir, thanks.
And you have people like Kaja Modin also, who is, very field oriented.
Thank you, sir.
So nice.
Yes, sir.
Thank you, sir. Thank you much.
Thank you, sir.
Thank you.
Sir.
Thank you.
Sir.
Thanks a lot. Thank you.
Thanks for patiently listening to whatever I said. Thanks.
Thank you, sir. With that, thank you, Subramaniam sir, for your excellent and very knowledgeable and it's current trending topic of our industry. Thanks for upgrading our knowledge to the class that is needed, because the competition is also moving fast and the competition is not visible. That's the final story that we can. It's very clearly said is like, the competition is not within us. The competition is elsewhere. It's going to be the IT industry. So let us all upgrade ourselves and take it to the next level. And let us ensure that we as an MEP engineers or HVAC engineers rule this industry even for next 100 years. So that will be the closing note for this particular session, sir. We will do that. Sir. Thank you, sir.
Thank you. Bye.